should have discovered in your homework was sometimes you were working along, you had variables on both sides, and when you tried to get rid of them on one side or the other, they disappeared on the other side too. Did that ever happen?
Yeah.
Yeah. So you're working on, did you feel like, I must have done something wrong? Is that the kind of the feeling, the thought you had was, what happened here? I must have done something wrong? Well, one of the things we have to make sure we understand is that there are times that the variable can eliminate. Let's first talk about an identity. This is a vocab term here. When I say an identity, here's what you should think. You have an equation, you have an equal sign in it, that is always true, no matter what value is substituted for the variable. So you have this equation. I'm not just talking about an equation like 3 equals 3 necessarily. It could be x plus 3 equals 3 plus x. That would be true, wouldn't it? Wouldn't x plus 3 equal 3 plus x? So, whenever you have an equation that is always true, no matter what you put in for the variable, in other words, no matter what you would put in for x on either side, you have to put the same thing in on both sides. When you add 3 to it on both sides, it's always going to be, they're going to be the same thing on both sides. So when we have an identity, the solution is always going to be the set of all real numbers, and that's how we say it. And when you think, why do we have to call them real numbers? That's the set of numbers that live on the number line. All the real numbers are the number line. Well, guess what? There are some numbers that don't live on the number line. They're called imaginary numbers. We're not going to deal with imaginary numbers in Algebra 1, but come Algebra 2, Advanced Algebra, and classes beyond, you're going to have to deal with imaginary numbers that don't live on the number line. So when we talk about an identity, we want to make sure we understand that there can't be an imaginary solution. There are only real number solutions. So the set of all real numbers. Okay, you guys already know how to solve that one, so go ahead. Do that right now, please. Go ahead and solve it, because remember, there's lots of different ways to start it. But I'm going to suggest that you simplify both sides first. Or you might not have enough lines to show your work. I would simplify both sides first. Again, some of you might have taken a different route than I did, Brendan. Did you raise your hand? Did you have something to say? No? You did? Okay. So, some of you might have taken a different route than I did. I did do the simplifying first, and I decided, okay, the left side simplifies to 11, take away 5x, and the right side simplifies to a negative 5x plus 11. And then I said, well, okay, got x's on both sides. I'm going to add 5x to get them off of the left side. Well, then here's what happened when I had to add them to the right side. I got rid of them on the right side, too. I just got rid of both sides. So now I got 11 equals 11. Is this a no solution then? No, actually, remember what it says? It's an identity when, so an equation that is always true. Well, isn't this always true? Isn't 11 always 11? Yeah. So let's write this in our notes. Okay? When the variable eliminates, so when the variable eliminates, that's what happened here. It's gone. It didn't just eliminate on one side, it eliminated on both sides. So when the variable eliminates and the resulting statement, the resulting equation, it's a mathematical statement, equation, the resulting equation is true, like it is here, right? This is true, 11 equals 11. We're going to say the solution is all real numbers. Now, if you don't want to have to write all that out when you solve something and the solution is all real numbers, you don't get to do like Rn, say, well, that's real numbers, this is Rn, or ARN for all real numbers, or there is an actual mathematical symbol for all real numbers. So if you want to shortcut this and use a mathematical symbol, anybody happen to know what that mathematical symbol is for all real numbers? No? Okay. I'll show it to you. Here is the shortcut way of writing math. A capital R with a double sidebar. So if you are going to shortcut it, you're solving this problem and the variables eliminate and you end up with this true statement and you don't want to write out the words all real numbers, then that's the mathematical symbol you would use that I have there in blue. Okay? So if you ever see that in a math book or in a math problem, then you know what that stands for. And notice it isn't just a capital R because we might mistakenly consider that to be a variable, but it's not a variable, it's the mathematical symbol for all real numbers. Okay, so here's what I want you to do. And I don't want you to even talk to your table partner about this. I want you just to pick any number you want. I don't care what number you pick. You pick a number for x. You substitute it in to the equation and you do a check problem and see what happens. So you pick right here, fill it in. What number are you going to pick for x? Pick your own. Don't look at anybody else's paper. Don't talk to anybody else. Pick your own number. I don't care what it is. Put it in for x. See what happens. And into the original equation, not somewhere along the line after we got rid of some things and simplified, right away into the very beginning. Oh no, taxing some of your guys' brains, I can tell. So I use x equals 3. I got negative 4 equals negative 4. It checked out. X equals 3 is the solution. Would you try the parent group?
I did 1.
You did 1. And what did you end up with when you did x equals 1?
6 equals 6.
6 equals 6. Anybody else use 1? I guess it was maybe what? 6%. I hardly believe it was more popular than that. So did you get the same thing there? Did 6 equals 6? So in other words, x equals 1 is the solution also. So 3 is, 1 is. Anybody use a different number yet? You use 2, Michaela and Candace. What'd you get when you use 2? 1 equals 1. So is that what you get, Candace? Anybody else use 2? Okay, now 2 is a solution. Okay, somebody else. Give me another one. What'd you use, Cameron? 4. Anybody use 4 like Cameron did? What'd you get, Cameron, when you tried 4? 28 equals 28. Okay, well that's true, isn't it? So 4 is a solution. What'd you use, Brendan? You used what? 4? Okay, did you get the same thing Cameron did? Did you get 28 equals 28? Should. One of you should. You both should get the same thing. What'd you get, Cameron? -9, -9. Well, one of you did it, different than the other, and that should turn out the same. Only because when you evaluate that 4, it should only give you one value on each side. So anybody use a negative number? John, what do you use? Bud? You used 100. Way to go, John. Okay, and what'd you get?
I got negative 489.
Equals negative 489? Huh. So 100 is the solution. Anybody use a negative number? Oh, really, you guys? You didn't want to try a negative? I guess I should have. How about 0? Anybody tried 0? What do you think is the deal here? We all checked different, well, some of us checked the same one as another person. What's the deal here? What did we just prove? Any number you use will work. In other words, any value you want to pick from the number line, will make that equation true. So that's why the solution is all real numbers. And how do we know it's all real numbers? Without checking the whole number line? Could we check the whole number line, really? Could you live long enough to check the whole number line, really?
No.
I don't care how young you guys are. You guys are pretty young, but do you really think you could live long enough to check every possible number on the number line? Because it goes on to infinity, both directions. No way. Try it. Go ahead and try it. It's not going. You got better things to do. I agree. Okay, well, so that's what should have happened sometimes in your homework. You were solving along, merrily solving along, and the variables went away and you ended up with some number equal to itself. Did that ever happen in your homework? Yeah, then that's when the solution is what again? All real numbers. Okay, now let's go to the back side. Sometimes equations are always false. In other words, no matter what you put in there for the variable, it would turn out to be false. So therefore we say some equations do not have a solution is what I want to put here. Let's try this again. A solution. So do not have a solution. Circle those words. Some equations turn out false. That means they don't have a solution. You can try all day to find a number on the number line that would work. So go ahead and solve that one that's there for you now. So let's see what happens. See, means in reality, one for sure thing should happen to all of us, no matter which route we take. Oh, I discovered when I was going through some papers last night that some people think you can read subtraction backwards. You can try. You can't read subtraction backwards. This does not say, here's mine, this does not say 3 take away 13x. It says 13x take away 3. So we can't read that backwards until we change it to add the opposite. Now we can read it backwards and see that 13x is being added to negative 3. So do not read subtraction backwards. Now you might take a different route, so you might end up with something different than I did, but if you take the same route I did, this is what you'll get. I get negative 3 equals negative 4. So what do you suppose we're going to surmise here? What are we going to put down? We're going to say, the variables did what again? No solution. So let's write this out totally though. The variables eliminate. I want this in your notes. Is there anyone that for the variables did not eliminate? Is there anyone who ended up with a true statement? So in other words, I can count on that variable eliminated for all of you, and you ended up with a false statement, some number equal to a different number. And if you couldn't get that to happen, steal my way then, I guess. The variables eliminated, I guess there was only really one variable, it was x, and the resulting equation is false. Therefore, there is no solution. So that's what we would put. Now, by the way, 0 is a solution. So 0 does not mean the same thing as no solution. No solution does not mean the same thing as 0. 0 is a legitimate number on the number line. It's part of the real number set. It does not want you considering it to be no solution. So, anybody happen to know the algebraic symbol, the math symbol we can use for no solution if you're so lazy you don't want to write that out?
Is it a backwards R?
No, it's not a backwards R.
It's a-
Yes. Okay, I'll show you what it is. If you want to not have to write out those words, you would put this.
It doesn't matter which way the crush.
Typically, I think it's written out. Let's see if it's on this chart. I can't remember if it's on this one or not. Those ones are not these. I think it can actually go like this. You might see it like that. But you know what? I would say probably just, yeah, let's just slant it like the way I don't even know what I did in the first place there. And then we'll know that we mean no solution by that. And here's what it really means. Empty set. In other words, there are no numbers we can claim to be solutions to this. That symbol really means empty set. That's kind of how we use it. Okay. You know what? I'm so disappointed in our word problem and our problem solving abilities. And we are not going to give up though. We're going to eventually have to be able to stand up here and say, I am so proud of you guys that you have persevered and you can actually finally do this. Okay, before we even start this, let's just run through the word problem expectations, the standard I've set for them. What's the first thing we're always going to do? And some of us still aren't on board. Some of us still haven't bought that ticket. Pick a variable and tell what it represents. Then what? Write an algebraic equation. In other words, use that variable in your equation. Then you will solve it, and you will give the answer a label if you can. Okay. So, write an equation to represent the relationship. Notice it doesn't say, write down what your variable is going to be and what it represents. That's given. You just get used to doing it. It's not going away. It'll still be here, May 2016. Okay? So, and then we're going to solve it. So go ahead, read that to yourself. First thing I want you to do is pick your variable and describe what it's going to represent. Okay? What's your variable? What's it represent? The number. We don't know what the number is. I'm going to use n. I don't know what you're going to use, but I'm going to use n. N is the number. We don't know what that number is, so that's what we're looking for. Typically, whatever it is we're looking for is what our variable is going to represent. Okay, go ahead and try. Don't even solve it yet, but just go ahead and try and set up your own equation for this. And then let's compare. Sage, you want to go up there and write yours? You're sitting there with oh, you're not done?
No, I'm done. I'll try it.
You're not, you can take your paper up with you. Okay.
John Sage.
You sit there down on the side.
Todd Sage.
Wasn't this one
You
on
guys,
the-
are you guys writing yours?
Yeah, wasn't this one on the homework?
Was this on the homework? I don't know. Tell you. Maybe. Thank you, Sage. How are you guys feeling about Sage's equation? Do you like it? Can we go with it? I love how, in this problem, it follows word for word from the first sentence. A number, that's n, decreased by, that's subtraction, 30, 30 is 30, is the same as, what would that be? Equals, is the same as. And then 14 minus 3 times the number. Oh my goodness, that looks exactly like what Sage wrote. Okay, go ahead and solve it. Was it in the homework?
Yeah, it was just under 35.
Okay, cool. You got a great memory. Oh, I didn't put 33 there. Who knows? Oh, I love when they work out so nice. Yeah, right. Whoopsie. Again. All kinds of crazy errors here. What's n equal?
11.
Did it equal 11 in the homework? I hope so. I hope we got the same answer.
Well, I didn't remember.
I can't remember. You know, and then, here's the other thing you could do. You could actually then, when you're not sure if you set your equation up right, remember, you should always see if you got a reasonable answer. But, you know, so yeah, you could go back up to the words. Don't check it back out in your equation, because what if you set the equation wrong? So go over there and say, and number decreased by 30. So you say to yourself, 11 decreased by 30. What is that? What's 11 decreased by 30?
Negative 19.
Negative 19. Okay, just in case our memories can't hold, we'll just write that down. Is the same as, so in other words, I better get that when I do this. 14 minus 3 times the number. Well, 14 minus 3 times the number. Well, 3 times my number, 3 times 11 is 33. 14 take away 33 is 19.
Negative 19.
It's negative 19, isn't it? Yeah. So if you had set this up wrong and you got the answer 5 and you went and said, okay, a number decreased by 30. 5 decreased by 30. Oh, let's see. What's 5 decreased by 30? Negative 25. Is the same as 14 minus 3 times the number. Well, 3 times 5 is 15. 14 take away 15 is negative 1. So we get the same thing on both sides? No. So again, you know what? You gotta learn this year. It isn't all about, you know, just avoiding having to stay after school to finish your homework. It isn't all just about, you know, you're gonna get the grade to get the money your parents are gonna pay you to get the grade. It isn't about that. It's all about the learning. Are you learning so when you go on to these other math classes, you're gonna be able to survive? Because trust me, after you get out of here, my students will come back to me like, can I be a 9th grader again? I'm like almost begging you, like, no. Sorry. Okay. So let's get out a sheet of loose leaf paper that you're going to be able to show your work on.